So hi guys, today we are going to discuss about Apache Spark part 3, which is our final part. As in our last two videos, you have seen about how to do partitionings, what are driver nodes, worker nodes, how Spark architecture will be there, and as well as what are narrow transformations, what are wide transformations, and as well as what are repartitionings, what is a DAG, how to read the DAG, and what is shuffling, how to do repartitionings and all. And these all concepts you have learned in your previous video. One small disclaimer: without watching previous video, do not watch this video because you won't understand anything. Now, in this video, we are going to cover about joints, how many kinds of joints. Do not think about left join, right join, cross joins, that what we have covered in SQL and all. No, those are types of join. Okay, what kind of join we are making. Okay, it is not like that. Spark, when coming to the big data, what we call Spark, when dealing with big data and all, that there are some certain joints will be there. How Spark used to make joints between the partitionings and all. So we all going to see those things and all. And Spark SQL engine. So as every time we are hearing that there are some what we call it as, when you submit the code, everything will be go into logical plans and all. Spark optimizes your code, and it will be went into your logical plan, sorry, physical plan, then DAG, all these things now. How Spark optimizes your code, and how many, and I have told in the beginning that there is something called as catalyst optimizer, how to optimize it. So that thing we are going to discuss in this. And how data will be stored in Spark, means how Spark will store the data either in memory or in disk. How memory management will be done in Spark, how driver memory management will be done in Spark, and for those driver memories and executor memory management will be done in Spark. And when you are dealing with data storing and all, you will get some errors which are out of memory, OMM errors, for drivers and executors. How you are going to overcome those errors and all, what is caching, what is persisting, what is unified memory management, what is Spark optimization techniques. You can't skip this Spark optimization techniques. Obviously, all the concepts that we are discussing in this video, most of the interview questions will be covered from this. So do not skip even 1 second of this video. So please plan like that. Okay, if you are not understanding anything, just rewatch this part again, or still if you are not understanding, you can freely come to me. That's it. Okay, so let us start. And before proceeding, let me go to my workspace, because every time when I'm opening my workspace, I have created my cluster and it will take some time. So that's why. Okay. And first of all, let me start my cluster. Okay. This is what the cluster I have created. Let me start it because it will take some time to start. Meanwhile, we can explain about the concepts. Now, come down. We are going to discuss about the joints today. Okay, joints today. Joints are, firstly I'm giving you, joints are Y transformations. Okay, initially it will create 200 partitions for you when you apply a join. Okay, but first of all, do not enter over there directly. I'm having two tables, student table and as well as fees table. Okay, what I have done, I have read this table by using this data frame. Df is equal to spark.read dot format. It is in CSV format. So I didn't wrote all the headers in for schemas and all. I have just read to for the space purpose. Okay. So I have read this table, student table, and stored it in this data frame df. So my df consists of student table, and my df2 consists of my fees table. Do not get confused. The student table will be there in orange colors. the fees table will be there in blue colors. You will get to know why I have segregated into two colors. Okay. And first of all, you need to understand one thing. The default size of partitioning is 128 MB. Do not think in such a manner that every time the partition size will be 128 MB only. If you won't change the partition size, then it will be defaultly taken as 120 MB. Usually, the partitions will be there from 500 MB to 1 GB, but Spark recommendation is to use 128 MB as one partition. Okay, now one partition size and Spark after crossing 1 GB. Okay, Spark won't recommend you to cross that one. Okay, what happens means, see, as we have discussed about the jobs stages in our previous videos, what happens for one partition, it is taking 1 GB. Okay, the entire job is running on top of it. The other partitions which are having smaller amount of size and all, they will run fastly, but this 1 GB partition will take a lot of time to run. Because of that, the job will get delayed. Okay, it will not give you the results at all. It will wait, the job will wait till the last partition get completed, then only the output result will be given to the driver node, and that result will be shown to you. Till then the job will be in waiting position only. Okay, and we are going to discuss what is a fix that we need to provide if any of the partition crosses more than 1 GB. Not 1 GB, if any partition is getting overloaded, okay, than the executor size and or memory and all, what we need to do. Okay, leave about all those things. Okay, we'll cover from now. Start. See, as if you have seen this one, I'm having two tables, okay, student table and this one fees table. I read these two tables. DF consists of my student table. DF2 consists of my this fees table. And this is first partition, second partition, third partition, fourth partition. Same like how first partition, second partition, third partition, fourth partition. Now what I'm going to do, I'm going to make a join. What is a joining key over here? Joining key is student ID. By using the student ID only, I'm going to make the join. Okay, but before applying the join, what happens? Before applying the join, what happens? See, this is my driver node. Okay, as driver node, by using driver node with the help of RDDs and all, the RDD will make the partitions. So my DF consists of these these four partitions as we have discussed before. DF2 consists of these four partitions as we have discussed before. Okay, if I haven't applied join for some time, let us take, I haven't applied join. What will happen means, before applying the join, if I hit, okay, if I hit df dot display action command before applying the join, if I have applied df dot display, if I have what we call it as done with my action commands and all, at that time what happened means is simply these are the two executors I'm having, but in my system I'm having only one executor which is treating as same driver node and as well as worker node. Okay, but here what happening means I'm having two executors. This is my executor 1, this is my executor 2, or you can say it as worker nodes also. Each executor consists of 16 GB memory and as well as 4 cores. As I have told, what are 4 cores? Each core, this is the first core, like that second core, third, fourth. As we have discussed in our previous class, each core will handle one partition, right? Leave about this one. Okay, leave about this one, you'll get to know. But before this, if I haven't applied any join over here, I have just directly done partitioning, and whatever the data which is there over here for me, okay, whatever the df and df2, this data is there over here for me. If I have sent this data directly to executors without applying the join, then what will happen? So that will be shown below. Okay, what will happen means, if you see 101 Rohit is there, what it will take the first core. And if you see, and one more thing you need to understand is, let me draw it for you, because see guys, before going into joins, let us discuss about how RDD will distribute my data without applying anything. You need to understand this first, then only you will understand about the joins next. So my RDD has done 4 partitions as per my requirement, as well as for DF and DF2. This is all RDD work. And RDD has distributed both of my data frames or both of my partitions to the executors. Good. You need to understand one thing very strongly, that see, my DF, I'm having 4 partitions. The RDD will distribute these 4 partitions to the first executor, and the second 4 partitions to the second executor. No, it's a very big mistake if you think like that. No, the what RDD will do, if consider if you don't have this DF2 for some time, the RDD will split these 4 partitions evenly to executor 1 and executor 2. Example, this is not there. These 2 partitions will go to first executor. The other 2 partitions will go to the second executor. Meanwhile, as this each executor consists of 4 cores, 2 partitions will be occupied, 2 partitions will be empty. Same like how 2 partitions will be occupied, 2 partitions will be in empty if you don't have DF2. Initially, what RDD will do? RDD will send this 101 to the first partition, for second partition. This is for executor to first partition, second partition. For you understanding, I have wrote like this. Okay. Generally, it will be in random manner. And once this DF1 was evenly distributed or scattered to executor 1 and 2, in executor 1, I'm having 2 empty spaces. Executor 2, I'm having 2 empty spaces. Same like how this 101 will take the empty space of first empty space in the executor 1, the second empty, third one, fourth one. You can ask me one question, Rohit. You are having 4 cores, 4 partitions, evenly it got distributed. Okay. What if I'm having 6 partitions in each data frame or in each RDD? Then what I will do, what it will do means it will evenly spread these 4 partitions to 2 executors, and the remaining 2, whatever the partitions will be there, those 2 partitions will wait in queue for some time to get complete of the tasks in the course. If any core will complete the task, the other partition which is there in the queue will be picked immediately, and it will process the data. So first thing you need to understand this, I haven't applied any join here. Okay, and let us understand how this will work. Okay, I'm having the actual data. How I have taken the data means, see, you can do it in MySQL also, as I'm having some issues with my MySQL. I'm using Oracle SQL Developer. What I have done is I have created what we call it as few tables. Okay, 2 tables I have created. Let me go over here. Okay, so within these 2 tables, I'm having 2 tables with me. The first table is std underscore table, std underscore tbl, and as well as select star from the other table. What is the other table? Fee underscore tbl. Okay, this is my first table, which consists of my student data, student ID, student names. And this is my second table, which consists of my fees amount and all. So now what I'm going to do, we are going to make a join between them. That's it. Okay. What I have done, I have exported this to my desktop. And then from there, I went into Databricks, not Databricks, Azure. And initially I went to my storage account where all my storage will be there. So this is my storage account. You can see I have created one source and destination. Okay. What I'm going to do in source, I have kept two files, std table, fee table. These two are CSV files. Okay. If you open this one, click on edit, you can see all the people, right? This is what CSV file, CSV format. If you go to fee table, click on edit, you can see all the IDs and as well as fee amount. Good. Now, what I'm going to do, I'm going to go to my destination, and within this destination, I'm going to store my data by doing repartitioning into four partitions. I'll do repartition means I'll do four partitions of my data and I'll store it initially as per the architecture that I have wrote over here. Then we'll go into the joins. Okay, you need to understand why, how you can configure that this data has done into four partitions like that. Okay, so initially this is my notebook. Okay, I need to let me open my new notebook. Okay, first of all, what I'll do from PySpark dot SQL dot functions import all functions I'm importing and as well as all types I'm importing. And there is something called as adaptive query optimization. Okay, that thing also I need to make it false. I think I have wrote it somewhere. Let me pick from there. Yeah, this is what my adaptive optimization, adaptive query execution. So I have make it false. Why? Because if this is there, it will not allow me to show four partitions and all, because it will optimize my query and it will give the final result to me. Okay, good. Now what I'll do, the data which is there in the source, first of all I want to read the data and store it in a data frame, right? What I will do, if I want to read the data, df, this is my first data frame, spark dot read dot format. What is my format of the file? CSV file. And come down. What it is, once it is done, I'm going to write the option header, because I want to make all my first lines as header true. And next come down, and what I'm going to name dot option, I want to make it as infer schema true. Till my last class I have uploaded my whatever the files are there in Databricks only. No, from now I'm going to upload my data in the disk. Okay, this is the memory. I'm not going to upload my data in memory. I'm going to, because all the data will be there in memory in real time industries, because sorry, disk not in your whatever your sorry, whatever your Azure is there, this is a disk. Okay, disk where your actual data will be stored. Databricks will fetch your data from disk to memory. From memory it will execute your query. This is what you need to understand. Okay, and we'll discuss about these things while when we went into the memory concepts and all, storage memory executions and how storage memory will be taken and all. So we'll go over there. Now finally what I need to do, dot load. See, whenever you want to read a file, okay, from data lake, you need to write something called as ABFSS, Azure Blob File System, that one. Okay, then you need to give two back hash like that. Okay, now what you need to do, you need to first of all give your container name. Container name, what is your container name? When you go to containers, where your store data is residing, your data is residing in the source. First of all you need to give your container name. Okay, then after that, at the rate in which storage account this container is residing, in this storage account your container is residing, you need to give that one. Then after that there is one common format is there for everything, dot dfs dot core dot windows dot net. Till here same. After this, see, after this, for suppose within the source, if my student table is residing within one more directory, like see, like students, I have created one more directory called as students. Okay, students. If my data is residing within my students, okay, like students, let me upload one more file which is there on my desktop. Where was that? Uh, See, std table. Again, I'm applying that table. Okay. If now I need to come into the source. Within source, I need to go into the students. Within students, I'm having std underscore tbl dot csv. Right. Now, after this one, after this net, if any files which are there in the source, any directories or any folders which are there within the source, you need to write those directories. What is the directory right now? My directory is within the students. Okay, within the students, I'm having std underscore tbl dot csv. You need to mention this one for sure. So then only it will go to Azure Blob file system from source container, which is residing in this storage account dfs.co.windows.net. This is common for everything. And within your source, if you are having any further folders, it will go into that further folders. And finally, this is what the file that you need to read. This is what the format you need to maintain every time. So if I have ran it, okay, it will take 1 or 2 minutes of time. And I have, as I have explained, read and as well as infer schema, these two are action commands. And here you will see two jobs over there which is going to get triggered. See, spark job one more job also get triggers over there. See, two jobs, the first job for read, second job for infer schema. Okay, nothing I will do, I will do repartitioning of this data. I will do repartitioning of this data, and simply I will write this data by doing into four partitions. Okay, how it will be done? See, see now I have got two jobs over here, right? Now first of all, let me check for this data frame how many partitions are there. Okay, because we are going to do four partitions and we need to write the same data in destination folder, right? Let me take this code again. Df dot rdd dot get num partitions. This is what the code. Let me remove this unnecessary thing and let me run this one partition. Now what I am going to do, I am going to create df underscore repart, something called as, okay, and here I will mention df dot whatever my df is there, repartition out of 4. I'm going to do 4 partitions because I'm explaining with 4 partitions. So that's why I'm going to doing 4 partitions. Okay. Let me run it. Done successfully. Now, this one I'm going to write to my destination folder. Where is my destination folder? You need to go to containers, destination. Within the destination, here I am going to place my folder. Okay. And when you see that one, when you open that folder, you need to show 4 partitions over there. Okay, let me go to my notebook. And what I need to write, if I need to write it, df underscore write is equal to df underscore repart dot write. What I am writing in this one, what is a mode, in which mode I am writing? I am writing overwrite. Overwrite means if I'm every time the data will be overwritten. Okay, dot option uh, header comma true, you can mention this one, nothing will happen. Okay, dot option infer schema comma true, this is also good, true. Next, dot load. Where you want to load? Same. First of all, abfss. In which folder you want to load this one? In destination container. Within your, see, if you see this one, within your destination container, you need to come across over here. And what you need to do after this one, destination container, at the rate, what is your storage account? This is my storage account dot dfs dot core dot windows dot net. So within this, if you want to create any new folder, see, I haven't created any folder in my destination, and here I'm writing students. Okay, if I create this one, automatically within this folder the partitions will get created. So simply what I need to do, let me run all right now. What it will do, I'm reading file from source, I'm checking how many partitions are there. Oh, what happened? Oh, okay, okay. I have done save. Okay, okay. What I'm doing over here, I'm checking how many partitions are there. One partition. Okay, one partition, and I'm writing whatever the repart has done to my destination. Now if I go to my destination, which is my data lake, refresh my tab, you can see something called as students, which got folder created just because of this. Okay, now go into the students. How many parts you are watching over here? See, this is a delta log. Okay, delta log, it is a quite what we call it as tricky thing you need to understand. It will be covered in Databricks. Okay, it has saved it in delta format. I do not want to save it in delta format, because delta format will always create a parquet file where you couldn't see the data in parquet file which is there in the encrypted format. Okay, let us give CSV over here, so that my part files will be saved in CSV formats. Okay, let me run all. I think it will show there is one delta log like that. Yeah, ran successfully. Super. Now, if I refresh this tab, go into students. See, you can see four parts are there, which means four partitions. If you open the first partition, okay, edit, within this partition only one or two Divya is there. See, I told now it will do as per the its wish. Okay, one or two Divya is there in the first partition. Okay, close this, open the second partition, go to edit. Here two people are there, 301 Ravi, 201 Tishar. Okay, good. Now, if you go to the fourth partition, these two people are there in one partition. Okay, if you go to other partition, edit, 2201 and Dina, these two people are there in one partition. And if you open the last partition, the rest of the people who are there, they will be, only Rohit will only there in one partition. So what it had done, it had splitted into my data into four partitions and saved it over here. So this is how my RDD has split my data into partitions and distributed to the executors. Okay, here I'm having only one executor, that is driver node and executor, both are same. Okay, now, now, now let us concentrate on joins. If I apply a join, how it will take? Okay, first of all, when I have applied any join, this is very important. When I have applied any join, same df four partitions, df2 four partitions. Okay, now as when I have applied join, everyone knows join is a y transformations. When we apply any y transformations, 200 partitions will be created defaultly. Everyone knows this one, right? And I'm having two executors over here. Each executor consists of 16 GB and 4 cores. With respect to cores, I have told each core will take one partition. 4 cores means each executor can handle 4 partitions. Okay, good. Now the problem over here is when I have applied my join means what? I'm combining this df1 and as well as df2. What will happen over here? As we have discussed below, as we have discussed below, all my df1 df1 means here Rohit could be there or anyone could be there. One partition of df will be occupied here, partition 1, partition 2, partition 3, partition 4, evenly sorted. This is for df2, partition 1, partition 2, partition 3, partition 4, evenly sorted. But problem over here is, see, as if you need to apply any join, if you need to apply any join in my first executor, okay, let me come down, you will understood clearly. This is the exact replica at below this one. 101 consists of this one. So this is what exact replica of above. What will happen? What happens if I give df.join? Till before I haven't applied any join. Whatever the data frames I'm having, I just split it into repartitionings and just send it to my executors, which got evenly distributed. And again, I wrote my data into my data lake. So you have seen 4 partitions are there. Good. Now, what if I have done any white transformations on top of my data frames? Example, joins are white transformations only. As we have discussed, if we have performed any white transformations, 200 partitions will get created automatically initially. Do not think that 200 partitions, okay, I'll explain, no issue. So what I have done over here, df.join df2. So I'm joining these two to get the how much fee I need to pay. Okay, as per SQL only. Okay. So when I need to apply any join, what is my joining key over here? Absolutely, my joining key is student ID over here, student ID over here. On top of it, I will apply a join so that I can grab student ID, student name, fees also. These two are from two other tables. Everyone knows, right? Come down. But there is one problem over here. The problem is whatever my joining key is there, okay, same joining keys from both the data frames should be there in the same executors. Okay, yeah, we'll continue. So as before, we have discussed about the joints and all, not that much. So we'll continue. As before applying the join, what I have done repartitioning up to 4 by 4 partitions, and those 4 by 4 partitions were splitted into executors, means they got partitioned, and they have taken uh, each and every core. Okay, one partition will be take one core. Everyone knows. Now there is something called as, if I apply join, okay, as per I told, join is a white transformation, right? White transformation. What white transformations will do? It will create 200 partitions by default. Okay, by default, it will create 200 partitions. And if it create 200 partitions, there is something called as, if any white transformation happened, there is something called as shuffling will happen for sure. What is the shuffling? Why we need to make shuffling? Shuffling is a process of shuffling is a process of redistributing the data or recomputing the data within the course and all. Okay. Example. See, if I do df1 dot join df2, simple. With what is a joining key for me? What is a joining key for me? Student ID. Okay. It is not the actual code. I have written wrongly, but for your understanding, I wrote like this. Okay. Next minute, what will happen? It will create 200 partitions for you. Okay. That thing I'll show in practical also. Do not worry about it. Now, what will happen after this? Once it is been done. Once it is been done, it will do one calculation. Okay, what was that calculation? Already I have told you about that calculation. That is what? Hash calculation. Hash. What was that hash? Already I told that one. Hash means what it will do. If I give any column name or anything, for suppose if I give my name over here, okay, any string value or anything, what hash will do, it will create my name into a long integer. Okay, like this. This integer will get mod. Okay, what is this integer? This integer I'll do percentage by number of available partitions. How many partitions are available for me? 200. Okay, most of the people will do by 2. Okay, so if I do 200, what is a reminder that I'll get? If I get reminder 1, okay, so this 1 is the partition ID. Okay, this 1 is a partition ID. This one is a partition ID. Parti1 partition underscore ID. Okay. If for suppose example, if I give hash of this 101, okay, it will give some number like this. It's not. It will give some number like this. Okay. It will do percentage 2. Sometimes we'll get negative values also. Do not worry about it. Sometimes we'll get negative values also. We need to make it positive. And if I get this partition as 2, now the partition ID will be 2. Okay. Now what will happen? All for suppose if 101, okay, for 101, 201, 301, some 102 got the same reminder as 1. So all these, whatever the rows are there, so these values will go into that partition number. This is what the main concept of shuffling. How shuffling happens? By this only. Okay. Now let us view in detail how it happens. Okay. Oh, remove this. Remove these things. Okay. I'll show it in live also for you. Okay. I'll show it in live also. What will happen means, see, if you want to take the partitions of it, okay, you need to do something. This one. So let me start my cluster. Start didn't started up. Okay. Okay. Meanwhile. Okay, let us wait until the cluster gets started. Once it gets started, we can continue again. Okay, how we need to get that calculation? Like I told now, like for the 101, if I apply hash on 101, I will get one long number. Okay, that will be done with respect to 200, 200, anything is fine. Okay, you will get one reminder. Okay, one or something. That reminder is a pure partition ID. How you can grab that one? That one we'll see right now. Okay. Now let us come over here to the notebook. My cluster is running. So first of all, from PySpark, from PySpark dot one PySpark dot SQL dot this one import functions, what not, what all these things. Okay. Import star everything. In this, if you want to, if I need to mention these things, I need to grab, take the hash column expr expression. You will get to know in the PySpark video what are those column expression hash and all. Okay, these are very important things. Okay, now when you came over here, you need to, no, comma comma this one, yeah. So you need to import these things. Okay, now first of all let us read our data frame, which is same like above. This one. Okay, take this date, take this data frame, read it. Okay, you will get some result. Okay, so after that, same like how I used to select from select statements and all, I will select over here the same also. Like see, I will write df dot display, df dot display. Let it run. Okay, now so this is my data frame and my data. So now I am going to calculate the partition ID. See, these things we won't calculate at all, but you need to understand these things. So that's why I'm telling you, okay, in very inch to inch manner. Okay, so you need to understand. Generally, we won't do any this kind of things. Okay, but you need to understand how the hash is converting my general ID or any yeah, string or anything into a big number, and how it is giving my partition ID. That thing you need to know. If that is fine, shuffling is very easy for you. Okay, so what I do as select, what I'm selecting, I'm selecting std ID, comma, std name. It had only given neatly. See, this is how select, that's it. Okay, like how we do in SQL. Next, what I'll do, as I have imported hash, if you have seen or not, what I'll do now, see, here I will write hash. What this hash will do, this hash will convert my column into the what we call it as into hash value. First of all, let me convert it into hash value. So let me take column, column of what? Std underscore id. Okay, std underscore id, std underscore id dot 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 alias. I'm giving alias name for it. What could be the alias name? It is a hash value, hash underscore value I will give. Okay, dot display. If I ran this one, see, see, when I have given this one, this is a hash value that I have got for 101. This is a hash value that I have got for this 201. See, sometimes we'll get, I told now, we'll get some negative values also. We can't get this value. This will be calculated by the this Apache Spark automatically. Now what we need to do next? Now what we need to do next? I need to put comma. Now we need to take percentage by 2. Again, what I'll do? Hash of column. What is a column name? std underscore id. This is my column name, right? Now, what I need to do this one, this std underscore column name. So what I need to do, I need to give as a percentage. Okay, percentage 2. 2 is fine. Why? Because 200 to anything you will get the same value. Okay, if I give 200 also, no issue. Okay, what I'll get, dot dot alias, give the hash mod value. Why these many? Okay, if I give this one, I need to write it within the expression expr, because it's completely an expression. What I need to write, hash of this particular column of student ID, and what I need to give, hash of the student ID, and and I need to know there will be one value 21474834647. So this is a value that I need to write, and once this value is done, I need to do percentage by 2. Okay, dot alias, and I need to write the, this is a partition underscore id. Okay, this is a partition id. So see, these will get the syntax errors, so that's why there is somewhere the code I have wrote it. Okay, better to get it from the Google only. Okay, now see, if you are writing any expression, better to write like this. Okay, if I have ran it, I'll explain what happened at that time. So you can see some partition IDs which are being visible over here, right? How it got verified means, see, it has done hash on particular student ID. So on this particular column, and get all these hash values. After that, it had done percentage by 2. Okay, percentage by 2, or if you do percentage by 200 also, generally we do for 2. Okay, you will get the partition IDs like this. Okay, that's why in generally we do percentage by 2. These are also different partition IDs, unique partition IDs that Spark will take, but for our understanding let us do by 2. You will get 0 0 0 1 1 1 1 like that. Okay, now Rohit, this one 101 has given the partition ID of 0. 201 Tushar has given the partition ID of 0. And 102 Deena and this Divya. These people have the same IDs. Okay. Let us note this in my over here. Okay. Or let us note like this. Okay. These are the partition IDs that we have got. Okay, so 101, he will get the partition ID 0. So in this calculation, what it needs to happen, what it will do after this means, it will perform whatever the calculation that I have told, this calculation. And once this calculation is being done, what it will do means, it will give how many people that belong to 101. It will align all the 101 in one partition. So what it will do, simply let me take something called as in red color, partition underscore 1. Okay. If I take partition 1, how many people will fall? 101, 201, and 102, and 202. These people will fall in one partition. And partition 2, how many people will fall in partition 2? Or sorry, partition, this is partition 0, this is partition 1. That's it. How many people will fall in partition 1? Only 2 people. That is what? Ravi, and as well as this 2001, this guy. Apart from this, all the people will fall in that partition only. Okay. So let us try to validate it whether I have done truth or not. So what happens over here is simply, if you haven't repartitioned it, what it will do, there are 200 partitions are available for us. Simply what it will do, for it will pick each and every person and it will place in one partition. That's it. Simple. If you have repartitioned it or decreased to 2 partitions like that, it will do in this manner. Okay, we'll validate both the scenarios, no issues. So this is how, and you do not need to prepare this one. Okay, why? Because I want to show you how hash key works, because so many people have doubt how hash keys are working and all, how we are getting partition 0, 0 and all, how data is getting divided into partitions, and how shuffling is happening. Okay, this is how shuffle happens. So the persons from 101, all the from other two executors want come to one partition, and from this other two, what we call it as rest of all the partition, the data is getting shuffled like that, and finally it will sit like this. And as I have told, what I have told, when join will happen, when join will happen, same keys same keys means same columns with the same keys residing in same partition, then only the join will happen. Okay, now if I have got this df these 101, for suppose he is from df1. Okay, there will be also another 101 will be there, he will also get the same partition ID. Yeah, for sure, that 101 also will placed over here. This is for df1, this is for df. For suppose let us take these all values are for df2. Okay, the df1 also 101 will be placed here, 201 will be placed here, 102 will be placed here, 202 will be placed here. Or because as the key same partition ID, the same key residing in the same executor, now join can be happened very happily. Okay, But the problem over here is shuffling is a very costly transformation. Shuffling the data throughout the partitions, iterating the things, it's a very costly transformation. Okay, but it is necessary to do. Okay, now this is how we get the partition IDs. Now let's come back to our notes. First of all, you need to import all the functions and all, run this. Okay, now we are closing the adaptive query optimization, because adaptive query execution, because it will not openly tell you you are having 200 partitions, these many partitions were used, these many partitions were left. Okay, and you need to off something called as broadcast join threshold. What is this? I'll explain you. There is one join is there called as broadcast join. if you are not if you are not offing this, okay, simply it will perform broadcast join for you and it will throw it off, and you'll get to know what is a broadcast join. Just wait for some time. Okay, now what I'm doing over here, for the first data frame I'm reading my student table. I have read my table, super. For df2 I'm reading my second table. Second table means fee table, this is student table. Okay, now in df1 I'm having student table data frame. In df2 data frame I'm having fee. Okay, simply if you want to view it, simply do df dot display. Okay, if you do df dot display, you will get to know easily this one. See, this is my first data frame consist of, and my df2 dot display, this is my second data frame consist of. That's it. Okay, now when coming to the, okay, already I have wrote the df2 dot display, done. Now coming to the point, uh before overwriting it, okay, first of all I won't do any repartition or anything. Before that I need to perform one join. Okay, I didn't apply any join yet. What I need to do, I'll do df underscore join equal to df dot join with respect to which data frame I'm doing, df2. Okay, comma, comma, I need to give df brackets of, okay, std underscore id equal to df2 dot df2 std id. Okay, why it is giving all these things? Okay, this one, and this one, which join I want to give, I want to give inner join. Inner join. Okay, this is a join that I want to make. Okay, what I'm doing with respect to student id, my columns are getting matched. I'm performing inner join. Inner join means nothing but normal join. Okay, so I'm doing this one. Let me run this. Join also happened. Okay, but before performing join, I want to check how many partitions are there for my df and df2. Okay, let us do df dot uh, get df dot rdd dot get number of partitions. Okay, if I want to check for df, I'm having one partitions. If I check for df2, okay, dot get number of partitions, I'll get one partition, because nothing happening, we are just reading. Okay, now once I have performed join, if I do df underscore join dot rdd dot get number of partitions, see how many partitions I'll get. 200. Why? Because this is a white transformation that we are performing over here. Okay, now let us write this data. I'm not going to do any repartition right now. Let us write this data as it is to my destination folder, and we'll check how many partitions that it will provide for me. This is the first thing you need to do. See, understand the Spark in a very, what we call it as, playful manner. That's it. Okay, you need to do so many experiments on this. See, even though I have also got like this only, I've done so many experiments. See, it wrote my data in my destination where under wide. If I refresh this one, see, you will see that okay, we are having 200 partitions. White had given me one, two, three, four, five, six, seven partitions. What are why it had given like that? See, if you open this one and watch it, na, the zeroth partition will get the only column names. It doesn't know what it needs to do with 200 partitions. So that's why for each row it will provide one partition. See, the first row will only have the column names. And see, this is a partition name. Partition 00, this one. So many people will have what are hash bytes. Nah? Hash bytes. So many people have asked me what are hash bytes and all. Let me explain you once this part. Very small thing. How this ID has formed. Okay. This is what the ID. This is a part. Everyone know partition. Okay. This is a number. If first partition is been created, it will give the start with the 00 like that. Okay. And this is what the hash byte number hash byte number that was provided for your key. Okay, just a second. So I have wrote all these things for you. So if you observe the file name, okay, the part means it is a partition ID. Okay, 0000, this one. TID means in your DAG you can see one of the task number, na? That is the TID. Okay. And what is this 30? This is a unique identifier. This is what a job unique ID. Okay, job unique ID. For each and every job, one unique identifier will be created. And so many people are asking now, what are hash bytes? This is a hash byte. Hash byte will be there in this format. It will convert this into some encrypted format like that. Okay, this is basically used to do the data validation, deduplication process and all. That's a different story. Okay, now after that there is something called as 43 came for you, right? Still 196 over here. See, 390 from here to here, 46B, all these things and all. If you come over here, they, at last you can see 43 na. This 43 is a stage ID. At what stage ID it got completed, and one is how many tasks got attempted, and that is a task ID. Okay, this is a output file counter, no need to, but basically everyone will identify this one only. That's it. And if anyone want to check with respect to which task got completed, they will check this one. That's it. And do not think about it much. Okay, but you need to know because while reading the files and all. Yeah. Now when you come over here, this is the first time. If I go to the second partition, this is a 1 2. It had given 1 2 like that. Okay, now after that, see here, if you see, Rohit will come first ID. If you see the second one, the other person will come, Dina. The other partition, one more person will be there, because it had 200 partitions. It don't know what to do, so that's why it had given each and every person one partition. So how many partitions are there? One, two, three, four, five, six, seven. You, why Rohit? Why seven people are there? We are having only six persons now. For the first partition, it had given the column names as a values. Created separate partition for that because it's a CSV file. Okay. Now, out of seven partitions is required for us. Okay, seven partitions were done. How many empty partitions are there right now? If you remove 200 minus what you got as 7, you will get 193 are empty partitions. Those tasks will be skipped. This is what actual game flows. Okay, if I do repartition, like I'll say, boss, I don't want these many partitions, 200 partitions. It needs to complete it within two partitions for me. Okay, then what I need to do, I need to go over here, simply come over here. After doing joining, na, what you will do, you do something called as repart. I will write something called as repart. Here what I will write, df underscore join dot repartition. Okay, how many repartitions I'm doing? Let us take I'm doing only two. Okay, repart. Let me run this one. Ran successful. Let me now try to get how many partitions are there with the repart. Two partitions. Right. Now I will write this repart over here. See, repart. Okay. Now let me run this one. Or you can run the entire notebook also. Nothing will happen. Okay. So all the jobs executed successfully. Yeah. So we have ran all our jobs. This time I have created only two partitions, repartitioning. Let us see how many partitions got created over here. Two partitions, right? But there will be some small issue you could able to see. As per our calculation, if I take all these people, these all got fit in first partition, right? But that's wrong. Why? Why that is wrong? As per our calculation, 101, 201, 102, 202. These people should come in the zeroth partition. But who came? But who came? The other people came. See, let me take it to a side. Oh, wow. Okay, let me take it to a side. Okay, who came? 101, 101. Okay, 301. 301 should come in the other partition. 102. He also got messed up. Why? Why? Because, see, what Spark has done is Spark has segregated your result like that only. Okay. But when you have performed repartitioning, repartitioning, it will not again shuffle the data. Okay. Do not think that it will shuffle the data. It will give as its own manner. Okay. But if you want to partition your data, like how with respect to the hash number of columns and all, at that time what you can do, you need to apply one more thing. What you need to apply? What you need to apply? You need to apply one thing. That was, see, remove this one. And other partition also, there are few people are there which are not related to each other also, partition IDs. They have split as their wish. Okay, 202, 2001, no. It's completely wrong. Now what I will do, I will remove everything. Okay, let me go to my notebook. Okay, what I will do, I will put comma with respect to which column I want to do repartitioning, that I want to give. Okay, with respect to which column of std underscore id. With respect to this column, I want to do the repartitioning. This column was already been partitioned with respect to hashes. So it will take those hash values. Based on that, it will do partitioning. If I run it, I hope I'll get some error. What it is giving ambitious. Okay, I need to change it in the data frame. What I need to do, what I need to do, what I need to do. I need to change it in the data frame itself only. What I need to change df dot this one, but I can do one thing. I can do one thing. Let me, every time writing like this is not possible. See, use these things you will learn in PySpark. Okay, I will write df1, something called as df1, df dot alias. I'm giving alias as a. Okay, come on. Okay, df2, equal to df2 dot alias as b. Okay, now it's my wish. Now it's my wish. What is my way? What is my wish to do? Now I can give whatever the column names are there as per my thing. Now I'll do df1 dot df1 dot join with respect to the df2 dot join, and here happily I can use something called as column. It is much efficient to do. Okay, column of column of a dot a dot df not a dot std underscore id. Okay, equal to column of b dot std underscore id. I hope now it works. Okay, let me run it. Yeah, it ran successfully. Let me run all my notebooks. This time all the notebooks will run successfully. Because why? Column of student id, which okay, I have given student id. What's wrong with that? Let me do something called as a dot. Let us give a dot and run. With respect to a dot student id, I'm running it. All ran successfully. Do not think about these things much. Why? Because you will get the PySpark video where all the things will be covered. Okay, nowadays very hectic. Now let us refresh these things. Now also you'll get the two columns only. Now let us check whether it got divided as per our calculation or not. Okay, now let us take these values and let us go to our workspace, paste it here with the first partition value, and let me go to the second partition over here. Let me click on edit. Let me take these two values and let me paste it over here. Now you please check whether the values have got repartitioned with respect to my column or not. Yes, 101, 201, 102, this one 202, 4. These in this I have got only two values only. So this is how you will do shuffling and repartition your data by applying the joins. Okay, but I have explained how join will work. See, till here join is fine. Now, whatever the join that we have done right now, the name of that join is called as sort merge join. Sort merge join. This is the first join that we have done. This is a sort merge join. What is this join? So in the initial stage only I have discussed sort merge join. So the join applied right now is a sort merge. Okay, what sort merge have done over here? Okay, see, if I go to DAG, okay, if I go to DAG, or before that, let me explain you what is a sort merge join, and let us now then go to DAG to read what is my DAG will show. Okay, I have read this one, I have wrote this one. So let me do df underscore repart dot display. Okay, if I have ran it, I will get to see something like that. Okay, if I go to see student ID, student ID, student name, two data frames got combined. Now, if I go to job 88, see, see, this is what happened. Okay, exchange. Yes, we have ran it so many times. Let me go to SQL data frame. Okay, let me display this one. I think it will just display this one. Yeah, I want this one. This is what sort merge join. Okay, what sort merge join will do. See, this is my first CSV file, which consists of my uh, student student table. Okay, so you can see student ID, student name, file scan. This is my student scan of other table, department ID, department name, right? What it had done, it filtered the records, given 6 rows output. See, filtering means it will just make sure not to get any duplicate null values. That's it. It because if duplicates are there or any null values are there, it is very much hard to perform the things to Spark. Okay, so that's why initially it ensures not to give any kind of duplicates or anything for you. Okay, now once it is been done, then what happened? Then exchange means what? Shuffling. Here, what Spark will do, Spark has created 200 partitions each. If you have seen this one, this exchange belongs to the first one. The other partition exchange belongs to second one. You can see something called as hash partitioning over here. Right? Come down. If you come down over here, the data size is very minute, which is 192.0 bytes, and the other one is also 144 like that. Okay, how many partitions it had made? 200 partitions. Okay, records also 6 by 6 it read. But see, 200 partitions it made, it doesn't mean that it shuffled our data into 200 partitions. Okay, that's completely wrong. Okay, now after that I told you there is something called a sort match join happened. What is this sorting over here? What is the sorting over here? So one sort has done. This is what the merge. This is what merge had happened. Okay. And after that, what is this one? Then merge. And finally, somewhat of exchange happened. Okay. And again, why exchange happened? Because I have again done something called as repartitioning over there. So that's why it happened. Finally, it collected. And what is this sorting over there? Okay. Sorting means nothing. Like, first of all, when you have taken the data, let me go to my screen. Let me go to one fresh page, which where nothing is there. Okay. What are the values? So let me copy these values. Okay. Copy. Go to one fresh page where nothing should be there. Yeah. Now paste it here. Okay. Should be in black color. Okay. Now remove this one. Not needed. This one also not needed. Fine. Okay. Now, as I have told, Rohit, this what we call as Tushar, Divya, Deena, these people will go to one partition. I told now. So when these people go to one partition, so there are two sides are there. The other data frame, sorry, black color, come up, uh, come up like this. Now, so this is the data frames that we are getting. Okay, two data frames. Initially what happened? Exchange had happened between the data frames, right? If exchange had happened, how the partition will look like? How the partition will look like? If any exchange had happened, let me take one common partition over here like this. Okay, let me come up. No, let me come up like this. Okay, now let me take it as a single partition. One shuffling is been done. Okay, this is what shuffling has done. Okay, now shuffling has done. Now what happened? Now shuffling has performed. Now shuffling has performed. Okay, now once shuffling has performed, what will happen over here? Nothing. I told na all the people which belongs to data frame 1 will sit in one area. All the people which belongs to data frame 2 will sit in one area. So who will sit in one area? 101, 201, 102, 202, right? So if you come over here, the people from left side table means whom? Left side is a DF. Okay. And who is a right side table? Right side table is a DF2. Now, once my partitioning is being done, okay, once my partitioning means shuffling. I told you shuffling will be done. Once I have performed my shuffling, what will happen now? It will be reshuffled the part like this. Means shuffling means as per that hash calculations, all the people which belongs to the one partition will sit over here. This is the first partition. In this partition, how it will get 101 Rohit, this one 201 Tushar, 102 Divya, 202 from this particular DF. 202 this one like this. It's not like they will come in order. No, it depends upon their availability. What Spark will do. That's why where comes the part of sort merge join. So it is easy to do sorting, but what it will happen now, if for suppose 101 needs to get joined with 101, it needs to read all the records from starting. 101, 201, no. It needs to record the next value. Luckily, next value is there, so that's why it will become a join. If not, it's very hard to become a join. If you go to 202, 202 is also fine. 201, see, Tushar is very hard to becoming a join. Why? Because it needs to first search 202, 101, 102, then at last Tushar will join with him. So that's why what Spark will do, first of all, it will sort with respect to the joining key. It will sort both the data frames and all. How it will take na, sorry. So now when comes to over here, what Spark will do, see, I'm not using any color gradings or anything this time. Let me use orange. Okay, so he is 101, 201, 102, 202, 202, right? Like that same what Spark will do na, Spark will again sort the columns with respect to the partition key only. Okay, what it will do, it will do 101 like this, 201, 102, 202. Now it is easy to make partition join with each other. So that's why it will do sort with two different data frames. Okay, sort. And once means first of all it will sort, okay, before setting into data frames. What it will do, these two are two different data frames only. First of all, these two data frames will get sorted each other with respect to 101, 101. See, this is already sorted only, sorry, 201, this one, all these things. Then it will get merged over here. So this is what this process is called as. The upper process is called as sorting. Okay, and this process is called as merging. Merging means coming into one partitions like that. Okay, so that's why again I'm telling, initially scan the student table, it scans the other table, come up. What it will do, it had done exchange. Exchange means default it created 200 partitions. 200 partitions, it doesn't mean it is not using all the partitions. Okay, come up. After that, what happened, sort merge join, it has sorted. Okay, sort merge join means before that it sorted each data frame. This is different, this is df1, this is df2. Okay, these two data frames sorted with respect to the that student id only. So as we'll do in sql na, that we will sort with respect to the order by with respect to that student id. So it will order by with student id in ascending order both. Once it done, then it will get merged each other. But again we have done one repartitioning over here, so that's why it is showing over there. Okay, shuffle partitioning type is one, and how many records were written two. And see, I have done repartition, so that's why it is showing number of partitions are two, and those things got collect and limit over here. This is what the DAG of shuffle merge join. I hope you guys understood with respect to the shuffle merge join very well. And when we use short, not shuffle merge join, sort merge join. Okay, but when we use shuffle, what we call it as sort merge join, when both the tables I'm having bigger tables. Okay, you will get to know why I'm telling the bigger tables and all like that. Okay, now when you come over here, this is the first type of join as we have discussed. Okay. Now the what is the second type of join? The second type of join is shuffle hash join, SHJ. This join, it is unable to view because it is very much critical. You need to configure the things and all. Okay, but I need to explain this, so that's why I'm explaining you. Okay, consider consider. Okay, let me take my what we call it as one partition. Okay, so there are, if you compare over our first thing, there are only few students are there, 101, 201, 102, 203 and all. Okay, let us take okay, for the first data frame. Okay, let us take for the first data frame 1, df. Okay, has so many students. Okay, let us take the df has leak for suppose Rohit. Okay, let me write over here. Okay, Rohit 1. Okay, let us take department ID 1. Okay, and Ravi department ID 1. Okay, Mohan department ID 2. Srinu department ID 1. Okay, Sarita department ID 1. Okay, Lokesh department ID 1. Okay, Hari department ID 2. Okay, there are almost all I'm having 10,000 people are there. 10,000 records are there with me. Only for the first DF. Only for the first data frame. Okay, which means this is a very bigger data frame and as well as bigger data. This is a very bigger data frame. It's not 10,000 records is not bigger, but I'm telling bigger data frame. Okay, for your understanding. If the data frames are there in lakhs and all, that becomes very bigger data frame. Some 70,000 rows and all, if you are having, that is a very bigger. 10,000 is fine. Okay. But for your understanding, I'm telling it's a bigger data frame. Okay. In my other data frame, there is something called departments. Okay. Let us take departments. DF2. See, if you compare everything, I'm having only two departments. The first department is, let us take mechanical. The second department is, let us take CSC. Only this college consists of only two departments. Okay. Which means what? Which means what? And there are so many like some other departments are also there, some 10 and all like that. Okay. But it should be some medium kind of table. Okay. Medium table kind of. Okay. But for your understanding, I'm telling 1, 2. See, it is like both that. Now what happened? I told initially what Spark will do. Spark will evenly distribute distribute to what? To partitions. Means Spark will evenly, sorry, RDD will create what? Partitions. Okay. Once partitions are done, what will happen? Once partitions are done, what will happen? It will get evenly distributed in the what we called as cores. Evenly distributed in the, sorry, distributed in the cores. Okay, when you applied any y transformation means what? Y transformation is for joins. Okay, shuffle. Okay, and as well as what are other things are there? Not shuffle, joins, group by aggregations. These are all white transformations. If you apply any white transformations, what it will do? It will first of all shuffle the data as per the hash formula, and it what it will do? It will do partitions. Okay, and whenever you do white transformation, defaultly you will get 200 partitions. Okay, and it will send the people who belongs to same residing key to the same partition. as per the calculation that I have also shown. Till here, for every join or every what we call it as um, to shove to every join or every group by, till here the process is same. But once the partition is been done, it will get diverted from here, because Spark will decide whether it needs to make a what either way it needs to make a broadcast join, or whether it needs to make a sort merge join, or whether it needs to make what we call it as shuffle hash join. From here, the process is same. White transformations will do, shuffle happen, but it is been there in one partition. Before going to one partition, what will one shuffling is happen? What it will do now? Spark will decide what kind of join we need to make. If it is a sort merge join, it will what we call it as join the things. Now the before we have seen the sort merge join, right? Now what shuffle has join means do, if I'm having very bigger table, and if my other table is a what we call it as medium kind of table, okay, medium kind of table, but definitely the other df2 is very shorter than df, then what it will do means, see, both the tables are shuffled, both the tables are shuffled, okay, both the tables are shuffled within those 200 partition, both the tables were shuffled. Now what will do na, this one, this will it will create a hash table. The df2 will create a hash table, or it is like as a lookup table over here, okay. It is very easy, okay. When we have a smaller df1, or when you have a smaller data frames and all, it will simply create a hash table on top of your small table, that's it. What is that small table? It is in a dictionary format, okay. Here it will create something called as lookup or hash table, okay. Lookup or hash table, these are being what we call it as distributed among the things and all. And what this will do, the hash table is simply like as a lookup table, it is like as a dictionary, okay. What it will do, it can quickly apply a join by looking at the table. See, simply what this will do now, it will come initially this df1, only one is there, okay. We'll look up in this, yeah, one is there, simply apply join. One is there, apply join. Srinu is there, apply join. Sarita 1, apply join. Lokesh 1, apply join. Harita 2, apply join. So hash table is simply like as a lookup table only. So the other df will just make a lookup on part of this df2. Like as a it is like as a dictionary. Within the dictionary, it will create like as key value pair. One, this two dots, this one. So if the key value pair is matching with this one, it will simply make a join with that. Okay. And because the hash tables are much faster, and it will go much easier to do. Okay. It will simply look up the hash table. So we need to make what we call it as, because it is very easy to fit in the executor's memory. You will get to know what is executor memory and all. So hash table will be saved into memory. Whatever this hash table is there, this will be saved into memory, which is our next concept that we are going to discuss, okay. So, and one more thing, how many hash tables are there? For suppose, if I have done repartition for two partitions, right? This hash table also will get created for both the partitions. How many partitions are there? For all, within all the partitions, this hash table will fit, okay. Beside like this, if I suppose there is one more other partition is also there now, where the other people will sit, there also this hash table will fit over there. But this is shuffled data. Again, I'm telling, both the data has shuffled. Shuffled means done with the calculation. Only this hash table will have the people who are having in this partition only. Remember this point very well, because whatever the join that we are going to listen next has much difference than this. Okay, like here I'm having in DF, I'm having only 1 1 2 1 1 1 2, and here also I'm having 1 2. That's it, because it has done the shuffle calculation. The people whose reminders are same, those partitions only it went over here. This is one of the partition. Okay, let us take this is a what a partition 1. If I'm having partition 2, if they are having what we call it as some other branches like civil and all, this there these two values will not be there, mechanical and CSC. There only CS, civil and as well as other branches people will be there. Within that partition data, it creates a hash table. You need to understand this very clearly, because you will get to know the difference between the broadcast join and as well as shuffled hash join. This is shuffled data. Shuffled data means what? Calculated data, which has been calculated with respect to the hash id key. And whatever the column names that we are getting, hash id key means what? Hash id key means this one. So whatever those, for suppose in my first data frame, if I'm having these two people, only this people will come, and these partition will be created as a hash table. That's it. You need to understand this point very clearly, then only you will get to know the difference between this table and the next table that we are going to discuss. Okay, now coming to the next one, which is a broadcast join. Okay, that is a very hectic, not hectic, very simple join only. Come down. The next type of join that we are going to discuss is broadcast join. Okay, shuffle has joins, we need to configure a lot. Okay, but broadcast join, I'll show you an example. Okay, now if you want to perform a broadcast join, definitely you need to enable this one which you have disabled before. And now you will get to know why I have disabled it. Why I have disabled it. So this one you need to remove it. Simply remove it. That's it. Okay. You need to remove it. If I remove it, then only I'll get to know. But what is this one? I'll remove this one. Copy. And I'll tell you what it will do. So this is simply, it is a threshold for broadcast join. Why broadcast join means, broadcast joins is similar to what we call it as hash join, but there will be no shuffling. There will be no shuffling at all. Why there will be no shuffling means, what happens? What happens means, as I have told, there will be computer driver node. Okay, there will be driver node will be there, and I'm having two executors are there. Okay, two executors are there. Okay, we know Rohit this stuff, explain other. No, you need to understand this one. Okay, this is an executor one, this is an executor one, this is an executor two. Okay, now okay, what happens, Rohit? See, what is a broadcast join means, as you take the above example only, for my DF I'm having so much amount of data, but my other department I'm having only two departments are there with me. Consider mech and as well as CSC. Leave about hash join. Remember, disappear all these things. This my DF consists of 10,000 records of the students. Only I'm having two departments, which is mech and CSC in my college. So one DF carries my student table, the other DF2 carries my department table. That's it. Okay. Now what happens? Now what happens, Rohit? Nothing will happen. See, instead of, this is a very small table, right? Small table has a capacity to easily fit into this particular executor's memory. Okay, small table has can easily fit in executor's memory. See, while we are declaring, we'll have given a 16 GB 4 cores. This 16 GB is a executor's memory. Okay, consider 16 GB, but let me, I'm telling 1 GB. Let us take 1 GB over here. Okay, but 16 GB, while you're declaring 16 GB 4 cores, you will give, that is what the executor's memory. Okay, let us give, this is I'm having 1 GB. Okay, see, instead of what this driver node will prepare RDDs for you and shuffling this data, it's a very small table, no need to shuffle. Also, you're having only two records. Why you want to shuffle all the things and all? What simply executor will say na, see, uh, executors, you do shufflings, all the transformations and all for df1. Simply it says you do all the, okay, okay, what you simply do is you do simply transformations and all for df1. Okay, where is df2? This what it will do means the driver memory, first of all it will keep the df2 with it. Okay, and what it will do, it will broadcast this df2 to this table and as well as this executor both. Okay, it will broadcast. Broadcasting means it will just give this df2 broadcasting to these two tables. So this broadcasting will happen whenever you are having a tiny table. Okay, whenever you are having any tiny table, then only broadcasting will happen. If you are having both large tables are there, simply apply sort merge join. Okay, if you are having what we call it as one small table and any other last tab, simply you do broadcasting. That's it. So what it will do, the df2 easily fits over here. df2 with full data. df2 with full data. I told now, remember the above hash one. This is not shuffle data. The full table will fit over here. The full table will fit over here. If not, initially what happens? Initially what happens? What we call it as, consider there are two executors are there. Let me remove this one. Come down, come down, come down. See, initially what happens, these are my two executors. These are my two executors. What will happen, the df1 has made with some let us take four partitions. Okay, the df1 has made four partitions. So df1 with partition id 1 will sit over here. So let us take orange is df. Okay, df1, and as well as p2. Okay, p3 will sit over here and p4 will sit over here. Okay, but I'm having only departments of two departments only. One department is for what we call it as mechanical, and two department is for csc. Okay, so this is what the df1 has easily fit into the partition. Okay, how many cores were balanced for me? There are four cores left. Four cores left in my both of my executors. Okay, now it's time to go to data frame 2. What is data frame 2 consist of? Data frame consists of df2, which is a very minor table. It will fit over here, the one single partition only. This executor one will be very happy. It will say that yeah, one p1 p1 is there. I can easily make joins with this. But this executor two will say, boss, how I can make party, how I can make joins. This particular p1 is not even itself there with me. How I can make joins with it? Then driver node will say, do not worry, brother. I will send you the things. Simply it gives this p1 over here. How it will give, if p1 is there, if d1 df2 is there with this driver node, and this driver node will broadcast this thing to both the executors, so that this table is very easy to fit in the executor's memory. So it will broadcast both the things. So because of this thing, first of all, shuffling will go, because I told shuffling is very costly transformation. Shuffling will get eliminated. And Second thing, what? Once shuffling gets eliminated, what is the second thing will happen? Shuffling done. Second thing, there will be the jobs will run very fastly because shuffling will take some time to get the jobs done. So that's why these are all joins which are there in the Apache Spark, and simply just an overview I'm giving over here. If your both tables are large tables, both tables are large, simply apply sort, merge, join. What sort, merge, join will do? Sort, merge, join, initially the data frames are being RDD will prepare the partitions. So when you create join, the all the things, all the partitions will be reshuffled within the 200 partitions. Okay, reshuffled within the 200 partitions. And after that, what will happen? As you know how shuffling will happen, shuffling will happen with respect to the, how it will happen, shuffling will happen with respect to the that hash calculation. Okay, based on that partition id that we got as a reminder, those values will go over there. First thing, once that was completed, immediately what will happen? Immediately what will happen? Immediately it will sort in both the data frames. It will sort in both the data frame. All 101, 101 will be there in over one. All 102, 102 will be there over there. So it will be very happy. Okay. Then after that, once it is been done, then what will happen? Both the data frames will merge and it will give you a result and finally collect it. This is what sort merge. And what is the second thing? When you are having, if any one of the table is medium, or both the tables are medium, or if any one table is medium, at that time try to apply hash shuffle hash join. The name itself defines shuffle hash join. It will do shuffling as per the hash calculations and all. Then it will create a hash table so that the other table is very easy to look up on this table and do the join. But this join till now haven't created yet. Okay, in my entire career, I haven't created this join. I have created sort merge joins. I have created this shovel hash joins and all. Okay, now, now, if one of the table is very small, once one table is very small and one table is large, instead of performing shuffling on this small table, simply do broadcast join. What is this broadcast join will do? It will broadcast the smaller table. The syntax is also very simple for broadcast join, and we'll see what broadcast join will do. Just a second, we'll see. Nothing. As we know, the both the tables are same now. Okay, okay. See, let us take df2. Both the tables are very small data frames only. Let me consider df2 as a broadcast. Let me do. What I'll do, simply get RDD number of partitions and all. And here, see, whenever you want to do broadcast, with respect to smaller table, write broadcast before that. Understood? Simple. With respect to what is a smaller table is there, before that just write broadcast. Okay, now run. Now before that, let me delete these partitions and all. Because if they will overwrite sometime, or they will, because I have wrote overwrite only, it will overwrite only, no issue. Let me run all. Let us see if we are having any errors or anything. uh, So this is what complete about joins. If you missed anything, rewatch this part again and again and again and again and again, because I want to explain this concept in a very in-depth manner. So that's why. Okay. So same thing happened, but you can see, bro, Rohit, same thing happened now. What is the difference? Okay. Let me go to the job 7. Let me go to the DAG. DAG. It's not storage. Here, SQL data frames. SQL data frames. Now, if I do what we called as not right repart dot display. See, the DAG has changed completely. Before the you can see two tables are coming like this. Shuffling happened. One shuffle happened. What we call sorting happened. All these things. Now table has changed completely. This is my first table, student table, and I have done DF to broadcast before this one. This is my second table, right? What it has done. See, let us first read the first table. First table, it has read those things. There are no partitions are there, nothing initially. It filtered it. 6 rows are there. Okay, fine. What other table has done means, see what other table has done means, this is my second table which consists of my salary and all. Okay, and because how you are recognizing second table, because broadcast exchange happened on df2 only. Df2 consists of the salary table. Okay, now filter non null values, there are no null values are there, that's why 6 by 6, fine. Now here is a process of broadcasting. See, you won't see any kind of shuffling over here. You won't see any kind of shuffling over here. Okay, simply it had given 6 rows and it broadcasted over here, and simply the join happened between both. There will be no shuffling, no shuffling between the partitions or something. But after this, I have done something called as shuffling with two number of partitions. I think I haven't deleted that. So because of that, it is showing to me like that. Okay. Now, if you see this one, this is what broadcast join. There will be no shuffling at all. Simply the table will be given uh, to this particular executors directly. Simply the table will be given to the executors directly. No shuffling, nothing. This do two tables will get shuffled, will be directly interact with this table and do joins. These two tables will get interacted. When you need to do shuffling, when both the tables are very bigger and one particular table will not fit in one partition or two partitions, so at that time you need to do the short merge join. This is what completely about the joins. I hope you guys clear with this. If you are having any doubts on this, please let me know. I will clear it off. Okay, fine then. Though, so the next thing we are going to learn is storage, memory, allocations and all. Okay, so the next thing we are going to learn and all, how the storages will go, how we store the things. No, but before that, I want to tell one thing about something called as Spark SQL engine. Spark Spark SQL engine. This is what Spark SQL engine. Oh, what is this? Every time you are telling our code will get optimized in Spark, your code will get optimized in the Spark and all like that. I told her there will be one logical plan will be there. That logical plan, after that the Spark optimizes the code and it will give the physical plan who will optimize the code. This catalyst optimizer will optimize the code. Every time I'm discussing these things with you, na, what happens actually means, see, what Spark SQL engine will do. Let me write the definition first because this question is everyone asking this question. Okay, that's why I want to discuss the things because some people are not able to tell the answer for this one. Okay, so that's why the main thing over here is it is used to. I don't want this. I want this one only. Okay, it is used to process. Okay, structured data. What is structured data? Structured data is tables and as well as data frames. These two are structured data. Okay, and the one more thing it will take care of. What was that? The system is used by Spark, and the execution. This is what one more of the what is Spark SQL engine means. Simply you can say it execution execution, yeah, execution system used by Spark. Spark. What Spark SQL engine will do? Spark SQL engine is used to execute our tables, data frames, all these things. So Spark use something tool called as Spark SQL engine to execute all our things. Now once it's done, okay, once it's done, the next thing is means example. If I want to tell you in some example format and all, for suppose if I have done select a DEPT ID comma something, I will write count of star, okay, from employees, 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 where I'm doing group by DEPT ID. This is what something called as my SQL query. Okay, what Spark SQL will do now? Engine. This is what this is a query that I have given to Spark SQL engine. What it will do? Let me put it in red color. What man? What you're doing? Okay, Spark SQL engine. What this one will do now? First of all, it understand the query. It understands the query. Okay, what he has written. Okay, I have written this one. After this, after this, it optimize my query. Okay, with what? It uses something called as Catalyst Optimizer and as well as Tungsten engine, so execution engine, so all these things. Okay, it optimizes my query. After this, what? It creates the execution plan. It creates the execution plan. Okay, I'm unable to pronounce execution something what I'm doing. Okay, it runs in a cluster. These are what the Spark SQL engine will do. Okay, there is something called as Spark uses some tool called as Spark SQL engine. It will understand your query, or Spark SQL engine is used to not only queries, even we are writing data frames also, no? Data frames are what? Data frames are APIs. Okay, APIs. Data frames are also APIs. Okay, APIs we will call data frames. So this will work on reading the query and as well as queries. That's why the Spark is been eligible to understand the APIs and as well as this one. What we call it as SQL queries also. It can run both. It can run Python. APIs means what? Which language we use? Python. For SQL, we use SQL. That's why these two are very important over here. Okay, done. What Spark? I don't know what this optimization will do. And this creates execution plan. What it will do? See, there are some components are there. Components. There are some components are there with this particular Spark. Okay, not Spark SQL engine. What is the first component is? The first component is Catalyst Optimizer. What this will do means it is a brain. It is a brain of Spark. This is a brain of Spark SQL. What it will do? This only analyzes the query. Okay, this only analyzes the query. And what is the next? This is very important thing. Catalyst Optimizer, what it will do? The people may ask questions on it, so please listen very carefully. Okay, this only analyze the query, analyze query, and after that, what it will do? It creates the logical plan, creates the logical plan, logical plan. Logical plan means what? Logical plan means what? If I'm doing, or in my above query, I'm doing something called as group by, right? It will say it has done some group by with respect to what DEPT ID. Okay, something called as it will do like that. Then what it will do? Something called as it will optimize the query. What optimize? There is something called as filter push down and column pruning. Okay, I'll let you know what is a filter push down, which means, see, if I have filtered this data with respect to some department ID or something, and later on again one more data frame, again I have applied one more filter condition, but it is not required. Spark optimizes it, and initially only it will do filter for all the things, and then it will do column pruning. Column pruning means with respect to what we call it as with respect to each column, it will do filter. That is what we call it as column pruning and all. Okay, prune, not pruning, pruning. Then finally, what it will do? It will decides the physical plan. Okay, this is what majorly driver node consists of. One of the what we call it as Spark SQL engine is a catalyst optimizer. This is the most important optimizer. This only decides everything. What is the next thing? Next thing is tungsten engine. Okay, what is this tungsten engine? This is a performance engine. Okay, what this will do? Tungsten engine will take care of the memory management. So whatever our data, whatever what we call it as these things will store now our data, or where our what we call it as our memory will reside. It will take care of memory management. Okay, once memory management is done, once memory management is done, what it will do? It will efficiently execute our memory in the CPU. Okay, efficiently execute our memory in CPU. Okay, and what one more thing, what it will do because of this, what will happen? Faster execution. This is what tungsten operates. If anyone asks question, simply tell me tungsten engine will take care of the memory part. What catalyst optimizer? Catalyst optimizer will take care of our code part. What our code we wrote, it simply prepares the logical plan. If any unnecessary filters, unnecessary code that we have wrote, it will simply do filter push down, and it will convert into one, and finally it will give physical plan for you. That's it. What tungsten operator, tungsten engine will do? Tungsten engine will simply give you the do the memory management, efficient memory management or something. Okay. Third one, last one is execution engine. These are all engines which are used to do perform the task. This execution engine is used to finally it runs the tasks. Okay, this execution engine will finally runs the tasks. Okay, finally runs the task. Okay, what it will do? It creates the tasks. Okay, and assigns tasks to executors. Okay, and whatever I told now, cores will perform parallel execution and all. So parallel execution also done by this. This is what Spark SQL engine. Okay, and you need to know one more thing is that how it will prepare the diagram or what Spark SQL diagram. Simply let me write it over here. Okay, because time constraint is there, but I want to make you understand each and every point. That's it. Okay, whatever our SQL query or whatever our data frame that we write. Okay, initially as I told, what it will do the catalyst optimizer will come to picture. It optimizes our code. Then what will happen? It prepares the logical plan. Then 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 it prepares the optimized plan optimized plan. Then it prepares a physical plan. After that, it will go to the execution engine. Okay, then it gives a result. You may ask, the what is a tungsten operator? A tungsten operator will do the memory management and all. Okay, so till what we call it as, till from here to here one thing, here to here one thing, here to here one thing. Okay. To make a join between them, both the data frames should have the same joining key, which should reside in the same executor. If same joining keys are there in same executor, then only I could make a join. If you see, I know you didn't understood anything, but let me make you clear. If you come over here, this is my first data frame, right? What my first data frame consists of, which was evenly sorted with 101. First partition was taken by Rohit. Good. Second partition 201, 301. Third one, this one. Fourth one, this one. Like that, only this data also been taken. But if I need to make the join, whatever my 101 is there of DF, the other 101 of df2 also should be there in the same executor. Either my this first df should come to second executor, or this df uh, second df2 should come to the first executor. Because if both the joining keys should be there in the same executor to make a join. I hope you understand this.